Okay, some volume work here. With cones and spheres, on the front page of your exam paper, you're given two formulae. You're given the formula for a volume of a sphere. Volume of a sphere is 4/3 pi r squared, where the r, the radius, is from the centre of the sphere out to the outer surface. It also gives you this formula for surface area there, and the same for a cone, 1/3 pi r squared h, where r is the radius of the base of the cone and h is its perpendicular height, and again another formula for surface area. Okay, so this first question, they're giving us the volume and we have to use that formula to find the radius. So the volume is 4/3 pi r cubed. I know the volume is 296 equals 4/3 pi times r cubed. So now I've got to divide by 3 there, which I want to get rid of that because what I'm trying to do is get the r cubed on its own. If I multiply both sides by 3, I get 296 times 3 equals 4 pi times r cubed. Now to get the r cubed on its own, I have to divide both sides by 4 pi. So I get 296 times 3 divided by 4 pi equals r cubed. And if r cubed is all of that, in order to get r on its own, I need to take a root of that. And if that was r squared, it would be a square root, but to get r on its own here, I have to take the cube root. Okay, and I'll show you now where that is on your calculator. So that's in fact the sum that we're going to put onto our calculator now, the cubed root of all of that. So let's fire up the calculator, and the cubed root button, you can see they're just above the square root button. So in order to do a cubed root, we do shift and press the square root button. Now inside here I need to introduce the fraction, and the top of that fraction I'm going to put 296 times 3, and in the bottom of the fraction I'm going to put 4, and pi, rather than type in 3.14, is shift and this button. So if we do shift and that, you can see there that what I've typed into the calculator looks exactly the same as what I've written down there. So when I press equals, that will give me my answer, and the appropriate degree of accuracy there would be 1 decimal place would be fine. So 1 decimal place is the 0.1, the next digit along is less than 5, so it stays as 4.1, and then in brackets put 1 dp to show that that's the decimal place. Alright, so just quickly go through that again. This is the formula as it's given. We're not calculating the volume, we're given the volume, and we have to rearrange that formula in order to work out that. Now you could make life a bit easier for yourself, I suppose, by working out values as you go along, but you start then to round things off earlier than you should. So if you can follow the steps that I've taken there to get to that point, and then using your new scientific calculators, you're able to put that in exactly as you see it there. Okay, question 2, similar situation again. We're given the volume, but this time we're given the volume of a hemisphere. Now a hemisphere is half a sphere. So if the volume of hemisphere is 7 pi, the volume of the sphere that will come from will be 2 of them. which we could call 14 pi. So that's the volume of the sphere. Now putting that into the formulae, we know that the volume, which is 14 pi, is equal to 4/3 pi r cubed. So rearranging that in the same way we did in question 1, first of all taking the divide 3, we'd have 14 pi times 3 equals 4 pi r cubed. Then divide by the 4 pi, so we get 14 pi times 3 divided by 4 pi equals r cubed. Now you could spot that those two pi's cancel there, but we'll leave them in case you didn't notice that. To get the r on its own, we need to cube root. So r equals the cubed root of 14 pi times 3 divided by 4 pi. That's what we're going to put in our calculator. So let's get it so it looks exactly the same again. So first of all we need the cube root, which is shift and square root. Then we're going to introduce a fraction inside there. The top of the fraction we're going to put 14 pi. Pi, remember, is shift and that. And then the bottom of the fraction we're going to put 4 pi. Press equals, and to one decimal place that will be 1.5 centimeters. Just noticed there that I forgot to put the times 3 into there, so let's do that again. Cube root, introduce the fraction 14 pi times 3, and on the bottom 4 pi equals, that's better, 2 point. And here we're looking at the next decimal place from the 1, which is bigger than 5, so that rounds up to 2.2 centimeters. One more of these questions to look at. So let's see what's going on here. So here we've got a hemisphere which is attached to a cone to make a solid. It looks like that. The hemisphere is a radius of 1.8 centimeters. The cone has a base radius of 1.8, so they're the same, and a height of 5.1. Calculate the volume of the solid. So what we need to do is to work out the two parts separately. First of all, we work out the volume of the hemisphere, then we'll work out the volume of the cone, then we'll add the two together. So the volume of the hemisphere, first of all, work it out as a sphere. So volume of sphere will be 4/3 pi times r cubed 1.8 cubed. So when you calculate it, again we can type that in so it looks exactly the same as what we've written there. Just make it better light than that. So fraction 4/3 pi times 1.8 and then cubed. It's got its own button on this calculator there. So 4/3 pi times 1.8 cubed equals 24.42. But that would round to 3. Now although I've rounded that off, I've kept the full number there. So I'm only interested in the hemisphere, so I have to divide that by 2. So volume of hemisphere will be the 24.4 divided by 2, 12.2. And its volume is centimeters cubed. Now we'll deal with the cone. volume of the cone, if we just come back here, look back at it on the formula, is 1/3 pi r squared h. So it's 1/3 pi times the radius squared times the height. So the volume of the cone is going to be 1/3 pi times the radius is 1.8 squared times the height of the cone, which was 5.1. So again, we should be able to get that looking exactly the same on my calculator. So fraction 1/3, move the cursor off the bottom, pi times 1.8 squared times 5.1 equals 17.3 centimeters cubed. So the volume of solid will be 12.2 plus 17.3, which is 29.5 centimeters cubed. So what you need to do with questions like this is look carefully, make sure you're aware that it's not a full sphere we're working with here, it's a hemisphere, so we have to half the volume that we calculate from the formula we're given, and so on. Good.